Okay, unfroze, and then I'm gonna stop the video. I'm gonna pick some students, and we're gonna go. All right, let's build you up. Let's talk about parents. 1/2 raised to the x. Let's start with you. What's when you plug in 0 for x? What do you get? 0, 1. When you plug in 1 for x, what do you get? When you plug in -1, what do you get? And then that should be enough. As I plug in bigger positives, what do the y values get close to but never get to? So there is a what right here? Asymptote. So you should at least know there's a horizontal asymptote. Those are parent points. Next. He's ignoring me on purpose. No. What am I going to do to all these points? I'm going to move them right 2 and what? Don't tell me that's hard, because that's all you got to do is move them right 2 and up 1. So, right 2 up 1, just to speed this up, right 2 up 1, right 2 up 1. And that's it, because that's all that's happened to the parent function without the shifts, if you will. But where's the asymptote located? That's your last question you have to answer. But I'd mark you wrong. Good. She just said 1, but it's y equals 1. And then the last person of the group has to answer the nifty little questions I have over there. Like, what's f of 2? 2. All that is to locate where does 0, 1 end. I just do that on purpose because I want you to track the points, not just copy a calculator screen potentially. What's the domain? All real numbers. Good. And then what's the range? 1 to infinity, and I already have the parenthesis. It doesn't, and we already said y equals 1 from the previous student. Ain't no thing, everybody. This is what I told you to do. And again, because I think we're still at a major introductory level, especially on logarithm graphs. I don't even know if you did exponential graphs last year either. It might be introductory on both. But what I told you to do was go back to the parents, and then, I should have said boo. How do I know it's log base 10? Because that's the invisible base, right? Then I told you to change this logarithm to a what? Exponent. So how do I do that? BB? Huh? And then all I did is have you plug in points for this. These are not inverses. These are exactly, you okay? That's a look at death right there. All right. Jeez. All right. All right, so this is just changing the log into an exponential, and then you can plug in points into that chart. Let's stick with that same student. But actually and then again, this is introductory level. This is how you graph a parent, and then you deal with the baby, with the shifts. But I plug in 0 for y, students, BB. When I plug in 0 for y, what do we get for x? 1. What happens when I plug in 1 for y, I get what? And what happens when I plug in -1? And then this should be enough to tell you that the more negatives you plug in for y, the closer x becomes what? But never gets to 0. He said 0 twice perfectly. So that implies that there's an asymptote where? At what equals 0? See, that x equals 0 because it's a vertical line. So there's a vertical asymptote for a logarithm, not a horizontal. Okay, so next students, what do we do to these points? We x-axis reflection. I'm just going to put x-axis. I'm lazy. All right, fine. And then +2 does what? To left. What do you do first? Reflect or to left? And these do affect no, they don't really, actually. All right, so I asked this first out. This is where my crabbiness came in. All I asked was, where does 1/2, -1 go on the reflection? What's the answer to that? 1/2, 1. And it took me a half hour to get that answer. And then I move it left 2. Where does it end up? Left 2. Fine, let's just do it. What happens when I reflect this point? What happens to it? Nothing, and then I just move it 2 left. And then this one, when I reflected, I asked, where does 10, 1 become? What does it become? 10, -1. That took a long time. And then I think it was just too early in the morning. And then 2 left. Where's the asymptote, though, students? Where's the asymptote located now? Yeah. No. Not even for that reason. X equals -2. So the first student said it was at x equals 0, but now it gets moved to left, so it's at x equals -2. And then the graph does look like this. Ew, a little shaky there. Then the last student of this group is, what's f of -1? What's f of -1? Nope. Oh, you're right. Long day. What's the domain? Everyone just loves when I get an answer wrong. There's celebration in the streets. Good. What's the range? And then the other student got this part. So that's already done. The questions I like because they really solidify the graphing. Actually, a lie. We're actually doing 3.4 and 3.5 combined. And it's not a big deal. What I had for those two assignments back in the past, I just condensed them a bit. And really got it down to the brass tacks, which is what's important without any like abstract questions at this point. We're kind of short, a little bit short on time as far as trying to get our Chapter 3 test done before Thanksgiving. Exactly. And then, getting so we have at least 2 to 3 days of review for the final exam in December. Really getting down to it. It's getting close. 1 month and 1 day away from Star Wars. Anyway. So our first concept of the day is change of base formula. This is getting a little obsolete, but I'm still going to make you memorize and know this. It's obsolete because Inspires. How many people are in Inspire? Raise your hand. How many people have an upgraded and they know have an upgraded 84? Raise your hand. Or a new 84. I don't know. There's not a lot of hands up in the air. So if you don't have either of those two things, then you have to use the change of base formula. Okay, so first of all, why is this answer 1.4? We should assess that. Because what's 4 to the first? What's 4 to the first? 4. What's 4 to the second? 16. And 7 is between 4 and 16. So the power that's on 4 should be between 1 and 2. Because again, a logarithm, you're searching for an exponent. This is asking 4 to what power equals 7, right? 4 to what power equals 7, right? Yes, Mr. Samuelis. Okay, so what's the change of base formula? Without a logarithm button that looks exactly like this, which 10 years ago no calculator had this button possibility, except maybe a special scientific. We had to use what's called the change of base formula. So in order to do, and the only two logarithms we have in our calculator are log base what? Log base 10 and log base e. You had to do this. You had to do log 7, log of the answer, close it by the way, divided by log 4, log of the base, and then you get the exponent 1.4. It could also be the ln button, ln of 7, divided by ln of 4. Notice you get the same thing. It could also be, but these buttons don't exist, log base 74 of 7 divided by log base 74 of 4. I know I picked a stupid number, but the base doesn't matter. As long as the bases are equal when you do log 7 over log 4. The only reason I show you these two are these are the two that are on your calculator. Before I answer that question, ma'am, I'm going to zoom back to show you what they show you. Look at log base b of x is equal to log base a of x over log base a of b. So the base on these logarithms could be anything, but we just have these two buttons, so we would use either the blue or the red. That would make the most sense. Okay, and I don't know what else to tell you about that. The point's moots if you do have alpha window, all right, and actually an Inspire does have that button, so it can be done as well this way. But here's the thing: you do need to know about the change of base formula. You really should be aware of it, and that's all I got to say about that. But anyway, I don't think I really need to cover these anymore. But what should the answer be between 5 to what power equals 19? It should be between 1 and 2. You better have a brain on this. You better think before you button push. Because if you mistype something and get like 84 for an answer, you know what doesn't make sense. Why is it between 1 and 2? What's 5 to the first? 5. What's 5 to the second? 19 is between 5 and 25. So it's got to be between 1 and 2. What's the next one? What should the answer be between? This one a little tougher, but it should be between 2 and 3. Because what's 12 squared? 144. And then 12 to the third is much larger, a very large number. So blah, blah, blah. This one's a little tougher to figure out. And then I'm going to be honest with you. The change of base is actually faster to type. I could type this faster than you could find that log button and actually do it. You know what I'm saying? This is faster to do it this way than to search for the log button. You know, anything I ever say, you shake your head no anyway, so I'm just going to move on. Anything. The sky's blue. No, it's red. All right. Okay. Sure thing. You got it. Did I say good afternoon, by the way? A logarithm is another way of writing an exponent. So if exponents have rules, and logarithms will have. So what I like to do is share the exponent rules again for the third time in forever. No, that's not the song. All right. What happens when you have a power? I'm sorry. Numbers of the same base multiplied together, you add the exponent. You know that rule. Again, I told you logarithms are screwed up because we don't know exponent rules well enough. If you have two numbers of the same base divided, you subtract the exponents. I don't have to reteach this. You know, I was yelling at first hour. I got crabby because I wasn't getting a lot of answers. What's 2 plus 2? 7. Get out. What are you doing? All right, I got nothing right. So then at this point, I'm like, this is it. You either know this or you don't. This is the third time I've thrown this on the board, these exponent rules. And you had them all last year, a big component of last year's notes. If you don't have it at this point, we got some issues. All right, so you got to get some of this stuff down so we can move on from this. Sorry for yelling, but it is true. When you have a power raised to a power, you multiply those exponents. All right, the reason I have these, and you really shouldn't have to write them all down because it's the third time we've done it, logarithms are just another way of writing exponents. So if that's the case, logarithms have these rules as well, and you had these last year. Do you remember them? Yes. Okay, in honors, yes, and then in regular. I know you did in regular. I was in the tutor room, you know, for those that came in and asked for help on this. And it's a little weird, I get it, but you got to get there and get it done so we can move on. So this is actually not a trick by me. There is something behind this. Numbers of the same base multiplied together, you add the exponents. What? Did you know log base b? What's b, by the way? It's called, I just said it. B is the base, and then r is the. And then when you do this logarithm, you get a what as an answer? And guess what you're doing with these exponents? You're what? Adding them. So I'm not convoluting that rule. It's true. Okay, fine. What you need to associate, though, is when you're multiplying, one logarithm of a product turns into a sum of two logarithms. And then you associate multiplication with addition. That's the minimum. That's the low end of knowing. But it's still something. And then division. Two numbers of the same base divided, you subtract the exponents. And believe it or not, these two things represent exponents. They do. Log base b of r is an exponent when you're done evaluating it, and so is log b base b of s. Right, but again, division's related to subtraction. And then you remember this rule, right? You pull this exponent out in front. Remember that from last year? One of the most popular rules. You okay over there? Yeah, all right, it happens. Pull that out, and then believe it or not, this is an exponent. And this is an exponent, and you're multiplying these two exponents. So in a way, it is the exponent times the exponent rule. I don't know what to tell you. You just got to have these memorized and be able to use them. In 3.4, it's annoying. The only existence, or why 3.4 exists, is wax on. Anyone? And that's always a thing that I say that it's just, those questions are there just for your practice so you solidify the rules. There is no other point to it. Why do we have to do it? So you solidify your rules. It's the only reason. But then I'm doing 3.5 because you're going to use these rules to solve a logarithmic equation. Right? And then that's the use of it. And then we're going to build on that as we get into, a little bit, I wouldn't say more complicated things, just different things. Okay? All right. Okay, and then by the way, let me zoom back a little bit and move up. The directions could say condensed. This side is the condensed form of a logarithm. Condensed means to turn into one or make it, smaller and nice and confined. Expanded means you turn it into maybe two or more logarithms. So that's the right side of this. So again, wax on, anyone? This first part in section 3.4 is all about just using these rules. So, what does this become? What's number 2? What color? Z. So we got the first one done. What's the next one? Okay, then guess what? This is a multiple choice question. You're all proud of yourself. You look at the selections, and none of them are. This isn't in there. You want to know why? There's one more thing you can do. I tricked you. It didn't happen in the first one, but it happens in this one. Think. No, it's not that. It's about the log 10. What's log 10? 1. And then, lo and behold, you look in the multiple choice and you see that. Because this is a ghost. So actually, I added something that didn't happen in the first question. It could be simplified, and you probably should if you can. Next one. Base 2 of x. All right, and then the last one, I'm just going to cover it because, you know what? Sometimes it is about listening, taking down notes, and then solidify it in your own brain instead of putting you on the spot. But what's the third root the same thing as? And you have to do that. This is why I say logarithms are messed up because we don't know our exponent rules. And then a division statement turns into 2 logs subtracted. And then what do I do with the exponents? For expanding, what do I do with these exponents? Pull them out, what? In front. And you just do it. And that's really what 3.4 is about. First one, we'll start with you this time. What's number 14, condensed? Or usually you write that as 5x, right? Do the next one because this is easy. Nope. This is the most common error ever. Wrong. It's just a big fat ln of what? X over y. Please get that math out of your head. Okay, it's a common error. Remember this. This happens all the time, and it's not true. It's ln of one fraction. So always when you condense, you just have one logarithm when you're done, not 2. Okay, next one. We'll go in reverse order there. So what do I do with this 4 first? Probably should take some order on this. Make it an exponent. Good. And then what do? What's the final answer? Big one, right? Notice how small I'm writing it. Because it's log of that fraction. It's not log over log. Big difference. Okay, last one. Ooh. What do I do with these exponents first? Let's zoom in on this. What do I do with these oh crap. What do I do with these numbers out in front? I make them up. No. Add them. No, you don't add them. What do you do with this 3? You make it an, I accidentally said the word. Oh no, an exponent. Okay, fine, I'll write it. But what does that make this become then? What do I do with this 3 raised to this power? Multiply. That's the exponent rules in action. Okay, so then this becomes ln of what? Plus, we still haven't handled that. ln And then what do? ln plus ln turns into, I'll put that up here. Listening. Nice. Oh, I don't have any other friends but Z. Okay. So we already went ahead and multiplied these two and figured out y to the third times y to the second is y to the fifth. Nice. True or false, number one? Emily. Or George or Frank or Charlene. We'll throw a little, which one is it? Charlene. It's false. I don't know. That's just a made-up thing. That actually is good to see because I think some people do that. And I told you had to do the second one. True or false for number two over here, huh? That's another false. There's just no, this is log base 3 of 7 plus log plus base 3 of x. So totally false. Next one, we'll go this way. True or false, number 3? No, you. I'm looking right at you. True or false? We're online right now. 4, same thing. True or false? Good, next. True or false? This is the one didn't I just tell you? This is one of the most screwed up things that students do. Not true. How are those nails looking? Oh, okay, got it. How about number 6, true or false? Everybody, true or false, number 7? Ooh. False. What should, actually, I don't even, this is made up. Okay, what about number 8, true or false? Put it on my desk. Don't get confused by the absolute value. It's definitely true. It's the actual rule. We're not done. That's 3.4. Now what we're going to do is move into 3.5. I have a question. What's x equal to? What is x equal to? Well, it's alive this time, but that's fine. I've been killing the skunk all year long. Did you do any math, or did you just do some matching? It's like matching solving. I've talked about this all year long, and I'm sick of talking about it. So now what we're going to do is move into 3.5, which is some basic solving scenarios, which you've already done. Your worksheet that I gave you before, on Friday to get ready for Monday, we had some solving. And the beginning of your quiz on the no calculator part written was all based off of getting the same base, right? And the reason you get the same base is you drop it then. Because if b to the x equals b to the y, that's only true if x equals y. Well, now you're going to find out the same thing with logarithms. We're actually going to run into this. If you get it down to log of x equals log of y, the only way that's true is if x equals y. Right? And that's this math. It's not doing logarithms. It's not doing exponents. It's doing matching. And you need to get that figured out. And if you don't have the scenario, then you have to go into something else. The most common thing is if I'm stuck in a log, change it to an exponent, and it works. It solves the scenario. Or, if I have an exponent, change it to a what? Log. But now I've added. We just learned some rules about condensing. So if you have on the same side of an equal sign, log plus log, you can condense that to one log, and then run into one of these two scenarios. Either a matching or a changing. And we're going to run into all of these when I do the notes. Some are with a calculator. Anyone? Some are without. And I'll pause for a second. I don't have time for this. I'm not going to bother you. So again, this is college notes. By the way, is 243 a power of 3? That's a tough question. Enumerate people, those that know numbers, yes or no? It is. Do you know what 243 is? It's 3 to the what power? 5. I didn't get it yet. Did anyone say 5? This is what I mean about getting the same base. Because then what could you do? What can you do with these bases now? Drop them. You better figure this out. This is what I mean about doing things over and over again, and then eventually it's got to sink in. This is what your whole non-calculator written part on the quiz was yesterday, the whole front page. Some of us didn't figure it out. Or, fine, I give you the calculator. Change it to a logarithm. Log base what? I will be very angry if you don't. Again, I told you if you don't know how to change this to a logarithm, you're going to fail. So log base what? 3 of who? equals who? Fail. If you don't get that, you're done. By the way, this is asking 3 to what power equals 243. What's the answer to that? 5. And then you divide. It's the same answer. I know 243 is a large number, and you're afraid of knowing that that's 3 to the 5th, but, you know, it's called numeracy. Look, what do I do with this? Okay, by the way, do I take 20 times 2 and make it 40 raised to the t? That's an abomination of who? Starts with a P, E, M, PEMDAS. This is an exponent. You can't multiply 20 times 2, so what do you have to do with that 20? Divide it. Now listen. Can I change 50 in my head to 2 to a power? Yes or no? Is 50 2 to a nice even power? No. 2 to the 5th is 32. 2 to the 6th is 64. I know what the answer should be between then. What should the answer be between? 5 and 6. But this is how you do it. Log base who? Of 2. Log base 2 of 50 equals, well, I'll be. That's the answer. And then log 50, just close that parenthesis, divided by log 2, change of base. There it is, 5.64. So t equals 5.64 as an exponent. So, here's a classic example of, well, no calculator on this first one, or you could change the exponent to a log. This one, get the exponent isolated into 3 positions, then change it to a log. Very simple. You did this when? Last year. Solve algebraically means no calculator. But I can't do this yet. Now stop for a second. You can't change a logarithm to an exponent until you get it simplified. So what do I have to do first in this first example I'll zoom in on? What do I have to do first? No time. Subtract 3. But then I got this arbitrary negative out in front. So this equals 2, but then I divide by a negative. I divide by a negative. I divide by a negative. Now, boo! 10. What does that mean? That means 10 to the negative second equals x plus 2. Logarithm magic. By the way, 10 to the negative second is 1 over 100. And then all you have to do is subtract 2 from both sides. By the way, 2 is 200 over 100. What? What's 1 minus 200? Negative 199 over 100. Boom! That's calculus. No, it's not. That's 4th grade. Do I take 3 times 4 and get 12 raised to this power? No. What do you do with that 3? Now, this one actually could be a no calculator problem. What is this? 32? You could make this a no calculator. What's the common base between 4 and 32? 2. 4 is 2 what? Squared. 32 is 2 to the 5th. What do you do with these exponents? What's 2 times x over 2? 2x over 2, which is, drop the bases, x equals 5. Or, change it to a logarithm. Log base 4 of 32 equals, and then if you went to your calculator, I think this is 5 halves. If you did log 32 over log 4. Yep, 2.5. And then you multiply both sides by 2, and you still get what? 5. Then the last two examples and our last moments together, just today. Sorry, it sounded a little scary. How many logs do you see in this one? 3. I don't have time for this. And you did this when? Last year. So there should be some sort of file in your brain activating right now that you did do this last year. Notice what I highlighted though. What do I do about ln plus ln? You turn it into one logarithm. You use the rule that we started off with the day with. This turns into one logarithm by multiplication. This is the rule, not adding. Okay, ln of one logarithm multiplying the two answer positions. By the way, what do I do with this too, though? Then look at this. ln of this equals ln of that. How do you approach this then? Just deal with this equals that. And now it's an Algebra 1 equation. You did actually solve this in Algebra 1. And then you did it again in Algebra 2. And then you did it again in here. So what do you have to do in order to solve this? FOIL, minus 3x minus 2x minus 5x plus 2. Subtract x squared. You can watch the end of the movie if I'm going too fast for you, but this is Algebra 1 I'm doing right now. And believe it or not, it's factorable. Boom! What does that mean x equals? What does that mean x equals? 1/2 and... But now you got to watch yourself. The only thing you have to check is... What happens when I plug in 1/2 where I'm pointing right now? You get a negative. Can you ln a negative? That's all you really have to check. When I plug in 2, what's 2 minus 1? Good. What's 3 times 2 minus, is that a negative or positive? ln of, fine. This is probably going to work. Again, I don't expect you to check it because the time, it'd be okay if you did. But really what you need to do is make sure you're not taking log of a negative. And then I will finish this video as you maybe or maybe not pack your stuff, but what do we do with this? What do we do with that? Division, but you better do what with this 1/2? Make it a what? Now watch the math that happens with this one. It's log of x over x plus 4 to the 1/2, and that equals 1. This is not a drop your logs question. What's the ghost right here? So this is log of base 10 of this equals this. I have my classic 3 positions. So what am I going to do? I'm going to change it to an exponent. And what's the 1/4 power mean? Square roots. Now don't faint. This is not hard actually. What I do next is And by the way, we are now in Algebra 1, Algebra 2. These are Algebra 1, Algebra 2 solves at this point. How do I free a square roots? I what? Square both sides. But I also square the 10. Freedom! And then what do? Distribute and then set it equal to 0. 0 equals x squared minus 100x minus 400. And unfortunately, if this is not factorable, how do I solve for that? Okay, so I'm going to go down a little bit here and show you that quick quadratic formula. 100 minus square root of 100 squared minus 4ac all over 2a You know why I couldn't care less about the negative? Because the negative would be log of a negative, right? So the only thing I'm going to touch on my calculator is 100 plus, not the minus. This is basically 10,000 plus 1,600. So it's, I think, 11,600 on the inside. Right? 4 times 4 is 1,600, added to 10,000 already. Enter, then divide that by 2. The other answer will be a negative, and that cannot happen. So that's what x equals. Got it? So I did finish the notes in some sort of a manner. And we'll produce that video if you want to watch at some point something that